Let us look at a question on pressure. So this question says the pressure and specific volume of the atmosphere are related as this expression, that is PV to the power 1.4 is equal to 2.5 into 10 to the power 5, where P is in pascals and V is in meter cube per kg. Now, what is the depth of atmosphere that is required to produce a pressure of 1.033 bar at the Earth's surface? Okay, so let's have a look at this diagram over here. So let us say this is the Earth, and you have a vertical column of atmosphere on top of it, and let us say the height of the atmosphere that is required is capital H. Okay, and this H will produce a pressure of 1.033 bar at the surface of the Earth. Now let us assume a small height, and that is an elemental height. This is the elemental height. Alright, now the top pressure is, let us say, P, which is acting on this. There is a weight of this volume of atmospheric air that acts in the vertically downward direction, and there is an upward force which balances this elemental atmospheric height, which is P plus dP, and the elemental atmospheric column height is d small h. Okay, so if I have to balance the force for this particular column, that would be equal to, so you will have a force in the upward direction. So let me say this is the column that I have. You will have an upward force like this, and there are two downward forces like this. So the upward force is the pressure into the area. Let us say the pressure of this is capital A. So this becomes P plus dP into A. This is the upward force, is equal to, you have a downward force which is W, which is nothing but mass into gravity, plus the pressure force from the top, which is P into A. So this is what you get. Let's resolve this. You get PA plus AdP is equal to the what is the value of mass? The value of mass is density into volume. Now what is the volume of this much mass of the atmosphere? That is area into length. So this is the mass of the atmospheric column, dH. So you get rho A dH into G plus P into A. Now you can easily cancel off PA from both the sides. Okay, and now let's move forward, and now you can cancel off A also from these two sides. So this would leave you with dP is equal to rho into G into dH. Okay, and we would get dH as 1 by rho G into dP. Okay, now if this is 1 by rho, now what is 1 by rho? If you look at it, rho is basically mass upon volume. So this is kg per meter cube, isn't it? If you take the reciprocal of it, you will get meter cube per kg. Now this is nothing but the specific volume, isn't it? So this becomes V into dP upon G. So 1 by rho becomes V into dP. Now the relationship between V and P was P into V to the power 1.4 is equal to 2.5 into 10 to the power 5. Now I need to get the value of V in terms of P, because the integral is with respect to P. Now where is the integral? Because this is the small length for the full height of the atmosphere, I'll have to integrate it. So it will become integral dH is equal to 1 upon G integral VdP. So the integral is in terms of P. So I need to find the value of V in terms of P. So that would be V is equal to 2.5 into 10 to the power 5 upon P raised to the power 1 by 1.4. Okay, so let's put it here, and we would get capital H is equal to 1 by G integral you'll get 2.5 into 10 to the power 5 upon P to the power 1 upon 1.4 dP. Now the limits of the pressure, if you go back to the diagram, the pressure over here is 1.033 bar, and the pressure over here is, let us say, 0 bar, because you are in space, isn't it? There is no atmosphere, so very little pressure as compared to the surface. So the pressure varies from 0 to 1.033 bar. So the limit of the integral would become 1 by G integral 0 to 1.033 bar. Okay, now this is bar. We need to find and convert this into pascals. So I would write down into 10 to the power 5. Okay, and 2.5 into 10 to the power 4, not 4 but 5, by P upon 1 upon 1.4 dP. So when you solve this integral, the value that you get is 69,462 meters, and that is after putting the value of G, which is 9.81 meter per second square. Okay, and when you resolve this, you get 69.462 kilometers. So you need a height of 69 kilometers approximately of this atmosphere to produce a pressure of 1.033 bar on the surface of the earth. So this was one very basic question on the concept of pressure. Thanks for watching.